let's get started. Good morning, good afternoon, everyone. Thanks for joining this webinar today, either live or the recorded session, which will be available on LinkedIn after the closure. I'm Simona Severini, VP Revenue at Modulos, and today I will be glad to be your host. But first, a couple of words about Modulos. So in the past years, we have been busy developing a truly data-centric AI platform designed to build good, and by good I mean accurate, fair, and robust machine learning models with a revolutionary approach. The platform's unique value proposition I'd like to bring to your attention to is centered around addressing your model performance challenges, starting by improving your data quality with actionable and system-guided recommendation, which tells you which data flows needs to be addressed and that could be detrimental to your specific machine learning model. This is revolutionary in the industry, a world first. In a few seconds, we are going to see how the platform can help solve a fairness use case in credit risk. But now, let's introduce the speakers. Elena Maran is our financial expert and sales executive, and Claudio is our head of product. Now, let's quickly go through the agenda. We will start by introducing the concept of fairness in credit risk application, followed by a deep dive into fairness in the lending use case. We'll then discuss a result comparison, and we'll inevitably touch on new upcoming regulation, such as the European AI Act. Last but not least, Claudio will take us through a hands-on session on our platform, showcasing our debiasing tools. Now, a couple of more things before getting started. We are running a poll on menti.com as we are interested to hear from you on the following question. What comes to your mind when talking of AI and fairness in credit risk decisions? Please let us know in 1 or 2 words. There are 3 ways you can actually provide your view. So first, you can scan the QR code with your mobile phone here on the slide. Second, you can type in the link below the QR code, which is also available in the comment sections of the webinar event on LinkedIn. Or type in the browser www.menti.com and insert the following code, 38361074. We will get back to it towards the end of presentation. Now, last thing, you can also drop your question either on the messages section on LinkedIn or by sending an email to contact@modulos.ai. Now it's time to roll. Elena, the stage is all yours.
Thank you, Simone, for the introduction, and welcome to everyone who is following us today. Let's get into the heart of our use case. But before doing so, I want to make a point to the fact that this is only one of the potential application of the data-centric approach towards fairness. Of course, the same logic would apply to any potential application, AI application, where fairness is of concern. Hopefully, during the course of the webinar, we will be able to showcase surprising results and to show that fairness in the search for fairness in AI does not necessarily follow an intuitive logic. And also that fairness is a topic that is more and more under the scrutiny of the regulator. We will go into details later during the course of the presentation. So today, our use case is to determine whether an existing or a new retail customer of a bank is eligible or not for a personal loan by classifying her or him as an acceptable or an unacceptable credit risk. And our objective at the end is to develop a fair model to assess the loan eligibility, which minimizes the bias relative to the protective attribute of gender. So our data set looks like the following. We have 4,000 observations for which is known whether a client has defaulted or not on their credit after the loan disbursement. And we will use this information as a proxy for our future credit risk decision aimed at assessing the eligibility for the personal loan. Broadly speaking, we can group the information at our disposal into three main categories. The first one is composed of those personal attributes, including demographic and the protected attributes of sex, age, and marital status. The second group of information contains the specific detail about the loan exposure, including its amount, its purpose, the existence of potential credit risk mitigants, so the presence, for instance, of a guarantor. And finally, we have information relative to the past credit history and the relationship with the bank. So other credit exposure, their repayment history, is sometimes they were late on their payments or not, and how long had they been with the bank, the tenure with the bank. Let's have a closer look at the composition of this data set. And please, let's be clear, here I'm not going to make any moral or ethical statement at this point, whether this data set is fair or unfair. Most likely, this data set was really descriptive of the market situation or particular credit policies that the bank was adopted at the time the data were collected. But what is clear from a description point of view is that this data set is unbalanced under more than one level. The more striking imbalance that we could see here is the relative distribution within the population of female and male individuals, with a 90% presence of male observation and only 10% of female. But going into a further level of detail and further granularity, we notice that also the risk distribution is unbalanced within the two groups, with 70% of the male observation being good credit for the bank and only 45% for women. Furthermore, the same is true for the risk distribution across age buckets, with a particular imbalance in the youngest population bucket, 18 to 30, and especially true for the female population. So we might ask ourselves, now, if we wonder whether using this data for a machine learning AI predictive model to do future credit decision, are we producing potentially unwanted results that discriminate against one of the group, perhaps female? Well, and if we believe so, how do we go about rebalancing this data set? We may want to follow our first intuition and think, well, if we rebalance the distribution of female and male individuals in the data set, perhaps the fairness of the outcome will be positively affected. Or we may follow a different approach, the data-centric AI approach, which, as Simone already introduced, basically relies on identifying the negative marginal contribution of each and every observations on our data set to the fairness of the model. Now, before I show you the comparison of the results using these two approaches, I think it's important that you get a high-level explanation of the data-centric methodology and the step involved to the biasing. Claudia will go into much more detail during the platform demo, but let me just go through it quickly. So the first step to approach this problem would be to upload your dataset, the same unbalanced dataset that I described in the previous slide. On a second step, you will train all the models that potentially describe our credit problem. And you will be able, on step 3, to select one, of which you will assess the performance. Most likely, the fairness of this model is not the one that you are aiming from. And that's where you start improving the quality of your data and the fairness of your model, following the platform recommendation and eliminating those observations that affect it in a negative manner. At this point, you will retrain your solution and reassess the performance. You will be able to repeat the step 4, 5, and 6 as many times as required for you to be satisfied with the performance of the model. And at this point, well, you're ready to make fair credit decisions. Now, let's look at the comparison between what from now on I will call random suppression of main records on the right-hand side and the data-centric AI approach on the left-hand side chart. Let me first specify a few things about the notation. The fairness will be read on the blue line and on the left-hand side axis of the chart. Lower numbers for fairness imply a higher, a better level of fairness of our model. The accuracy can be looked at along the orange line and the value read on the right-hand side axis of the chart. So in the data-centric AI approach, what happens is that we have an initial drop in the level of accuracy, which is expected because we're optimizing for fairness. But after the first iteration on our data, the level of accuracy is held more or less constant. A different picture goes for fairness. And as we can see in the charts, we steadily reach a very low number for fairness, meaning a very high level of fairness of the model. If we compare this result with what happens with following our intuition and randomly suppressing male observation to rebalance our data set, well, it's a totally different picture in a sense that not only at the 5th iteration on our data, we end up with an even worse level of fairness than what we started with, but also the trade-off between fairness and accuracy is totally inconsistent. So what did data-centric AI do differently from the random suppression methodology? Well, as we can see in these two charts, the results don't necessarily follow the intuitive logic. We would have expected that increasing the female population would increase the fairness, but actually, following the system recommendation, we ended up with a lower relative proportion of female sample in the overall data set. But what we did differently is increasing those female individuals which are a good credit. And at the same time, we consistently reduce the gap and the imbalance in the risk distribution along the age buckets. And this is true both for female and male observations. So I hope that this gave you a bit of the picture that the topic of fairness is not a really straightforward one. And there's a lot of thinking needed to achieve the expected result. But why bother at all about fairness in credit risk? Well, the answer is, it's of course a good ethical and moral practice to aim at ethical and fair decision-making in credit risk. And let's not forget the risk for legal liability or for reputational risk. But there is one more reason that will become immediately evident to you, which is the upcoming EU AI Act. The EU AI Act represents the broader effort to regulate the technology, and it will become the de facto standard with an extraterritorial aspect to it. So it will apply to all the companies that offer products or services to European citizens, no matter where they are located in the world, just like GDPR. It's not something very far from us because it's due for final votes in November 2022, so this year. And what it is it takes a risk-based approach to classify potential AI system. And surprise, surprise, credit risk will belong to the category of high-risk AI system, for which very strict requirement of dataset quality, accuracy, and yes, fairness, robustness, traceability and auditability and transparency will be required. Penalty for non-compliance will be really hefty fines, as high as 6% of the global turnover or euro 30 million, whichever is the highest. So let me get you home with a few takeaways from this first part of the webinar. So we've seen that exploring fairness is a very complex task, and achieving the desired level of fairness does not necessarily follow an intuitive logic. Following our system recommendations, we've been able to achieve fairness at a faster speed and at a lower cost than a traditional approach to debiasing would have. Through the data quality management and being aware on each and every steps that we undertaken on our data set, we can explain our result, we can explain our achievements in terms of fairness, and perhaps defend our case in front of a regulator or a potential auditor. This will simplify the effort to comply with the regulator. And moreover, we've been able to track in a consistent manner our fairness and accuracy trade-off, very well aware that both fairness and accuracy are very important topics for credit risk decision. This concludes the first part of the webinar. I'll give now the stage to Claudio, but before, let me thank you for listening to this first part.
Thank you, Elena. Thank you for the great introduction into the topic and for your nice presentation. I now have the pleasure to show you the Modulus platform and show you how you can make your machine learning data fair. To do that, I would like to again discuss our new data-centric AI approach, and which Elena has already briefly touched upon before. I will do that with a video, and I will then switch over to the platform. So the data-centric AI approach, it really embodies and builds upon the fact that data is never perfect. It always has impurities. And so this approach, it gives a framework to allow you to handle these impurities and to iteratively clean and improve the quality of your data. And it does that with these 7 schematic steps shown here, as already shown by Elena, which cover everything from uploading the data to training machine learning solutions, to iteratively cleaning your training data until eventually to deploy your machine learning solution. And so this process, it's quite flexible, it's iterative, and you can at any point in time stop, take your trained machine learning model and deploy it. All right, so let's go through this briefly. So we start with, as I mentioned, uploading the data set. So you can upload it via drag and drop. The platform will then perform some additional checks and bring it into our structure. And that's all there is to it. We then go into what we call a workflow. The workflow for us is really the definition of the machine learning challenge. So here you need to select what are the inputs to your machine learning problem and what is the label. The label is the quantity you want to be able to predict with your machine learning model. And so you do that. And then the next step is to select an objective. The objective is quite use case dependent. So there's generally no correct answer on which objective you need to select. And that's that. There are other like optional steps, which you can like do some more configurations, and then you launch it and you end up on this view here. Because then the AutoML, which stands for Automated Machine Learning feature, takes over. That one schedules all the machine learning training tasks. So you don't need to worry at all about training machine learning models. The platform takes over. And it will do that. And you will end up with a list of different machine learning models. And we are now at step 3. So here you need to select your machine learning model, the one you prefer. And I mean, this really depends on your use case again. Whether score is the most important for you, size, duration, it's really, there's no generally correct answer. So that's up to you and your use case. So you pick this solution and you can either download it right away or you can generate a dashboard. The dashboard is the starting point for further improvements of your machine learning model. Because as you can see here now, steps 4, 5, and 6, we enter into this iterative data cleaning route. So the first step, step 4, is we assess the performance first. So how well is our machine learning model doing? Step 5 then is we try to improve the data quality of our training data. And due to that, we then retrain our machine learning model. And then hopefully also the performance increases, which we will then evaluate again in the 4th step in the assessing the performance. So it's really a loop. You can stop at any point in time and you then end up at step 7. So let's look at them very briefly. So assessing the performance, like the first version, it's quite simple. Here we only have one data point. We then go in improving the data quality. Here it's quite critical that it's improving and we need to define what we want to improve. So in the video, for instance, we want to improve the accuracy of the machine learning model. The platform then launches the tasks, and what it gives you are those system-guided recommendations. What are these recommendations? So they're really a prioritized list of samples in your training data set, and they're ordered in such a way that the first samples are the ones which affect your training the most negatively. And this is visualized here in this example. Here on the left-hand side, here we have different images. The first one clearly a 9, but somehow it has wrongly been labeled as a 5, which had quite a negative impact. So the platform detects that. It tells you there's something wrong. So you look at it and you fix the things. And you then generate a new version of your data set, upload it to the platform, and now we're ready to update our machine learning model. So we retrain it with the new training data. And yeah, so the platform then takes over. It schedules the task and everything itself. We do a few iterations, and then we would end up in this case with something like this. So we have here the accuracy shown for different versions, iterations of your machine learning model. And you see how the accuracy increases over time here. And all that looks good. So let's say we're now ready to deploy our machine learning model. You can download it. They're already packaged. They contain all sorts of further plots, documentation, clients to execute them, and all that kind of fun. And yeah, that concludes the DCAI loop. And now let's not spend any more time on this. Let's switch to the platform. All right, so I will show you briefly how we solved the use case which Elena talked about before. So in that use case, what we had is we had a tabular use case. So this one is showing the historical data on how different people applied for personal loans. So we have all sorts of information, what they wanted to do with the money. We have some information like what their gender was. And then importantly, we have this column here, which is called acceptable risk. So in hindsight, of course, we can tell whether it was a good risk, which we encoded as 1, or whether it was a bad risk, which we encoded as a 0. For future clients, however, we would like that we have a machine learning model which is really good at predicting this one. However, as Elena stated, that's a high-risk AI application. So we need to make sure that this machine learning model is not only performing well, but that it's also not discriminating against protected properties, like, for instance, gender. So that's the setup. So we would now then start by uploading the data to the platform. So it's being uploaded, some additional checks are being performed. to not have you wait too much on those screens, I will now, cooking show style, already showed you with a prepared example already. So we'll now go to just another data set. And so that's what you would see if you've uploaded the data set and everything. So you get some additional properties here, which you can review. And if you're happy, we can then go into this workflow creation. As mentioned before, you need to here specify the inputs and your label. The label is this acceptable risk column, which we want to be able to predict. Inputs are all the other properties. That looks all fine. We're now at the objective, which we need to select. Let me just, for the purpose of this demo, just select accuracy. For all the objectives, we of course have a definition for you to make a well-educated decision with your domain expertise. Now there are some optional like configurations which you may be doing. I'm not doing them now. So I'm just going with all the defaults, let's say, and then I'm launching this task, this workflow, and it's now being initialized, and the platform will, you can go and get a coffee, and it will then, if you come back, you will see how different tasks have been launched. So the platform takes over all the work. Again, to not have you wait, I'll go to an already prepared example. Here in this case, for this example, we ran it for like 60 different machine learning models. And yeah, so they're all listed here. And you would then just see, yeah, that looks like a nice model. Let me create this dashboard to improve it further. So I have one data point now. I would like to have more data points. So we're now in the iterative cleaning loop. So first I want to improve my data, and I want to improve it such that my fairness improves. And one, for instance, measure for this could be equalized odds. For that one, you also need to specify what's the positive outcome for you, like the good risk, which we had as a 1, and then what's your protected feature, which you care about for this run, which is gender here. I then launch it. A task will show up right now, and it's now being running, and I will then get an output. This output then is also this like file with prioritized samples. And you would then like basically follow these recommendations. Remove, as in the example of Elena, remove, for instance, the negative samples. Then you would upload your data set again, and then we go into this retraining step. This one is again a form, quite simple. You just select your new version of training data. I'm just clicking here on things. And then you launch it. And that's really all there is to it. The platform then like handles the retraining itself. All right, so that's like the gist of it. And now I just want to briefly show you the results. So as shown in the example by Elena before, what we did is we performed the test with 2 settings. So we used undersampling, and in the first setting, we randomly removed samples from like the majority class. In the other one, we followed the recommendation which the platform gives you. And that's the result we end up with the random removal. Here you can see the green curve is the accuracy, more or less constant. The red curve is like the fairness measure, which, yeah, it maybe decreases a little bit, but not very much. Then let's switch now to the recommendations. Here you see the accuracy is more or less constant again. And the fairness measure, it decreases quite a bit. And as mentioned by Elena, a decrease here is good because that means that we have less unfair treatment then. So we successfully made our data more fair, which led to fairer models. And I think that's more or less the last step. So I can then just download the solution and do like all the deployment, use it in my services. But I think for the purpose of this demo, that's good from my side. And I would now like to thank you for your attention and hand back over to Simone.
Thank you very much, Claudio. So let's see in the meantime, what we got from the poll we run. So this is the result, and I can see pretty much two dominant words, which is regulation and discrimination. So I'm asking to you, Helena, so why do you think people highlighted the regulation discrimination when thinking about AI and fairness in credit risk decisions?
Well, it's obvious that the financial industry is getting awareness that there's an increased regulatory scrutiny to topics like fairness in credit risk decision-making. And the potential of unwanted outcomes is of course, a discriminatory type of outcome that discriminates against minority groups like, for example, different races, or discriminates across gender, female, male individuals. So I think that majority of respondents is well aware of this topic and is concerned that it will need to be tackled.
Excellent, excellent. So since I have you there, I received an email, a question by email, and is asking, how do you define fairness in general terms?
Wow, this is quite a broad question, but I'll try to provide an answer. Well, there is not right or wrong definition of fairness. There are some statistical measures for fairness, which is what we have used in the platform. In that specific use case, we use the equalized odd metrics because we thought that in a credit risk decision in retail banking, we want to give an equal chance to women or to men to be accepted and rejected to their loan application. But generally speaking, I believe it's up to corporations and society to adopt a definition of fairness that is aligned to their general principle, their general values, and their general ethical beliefs, and then be consistent to this definition when using AI to take decisions that impact individuals and potentially can discriminate amongst groups.
Thank you, Elena. And in interest of time, I think we have just enough time to pick another question. And I believe this one is more for Claudio instead. It sounds very interesting. Could you tell us what machine learning frameworks you're using?
Yeah, that's a good question. So it's an AutoML platform. So for you, that's to some degree abstracted away, but we use really all the state-of-the-art frameworks. We use Keras, we use TensorFlow, scikit-learn, so they're all in there.
Fantastic. To conclude this webinar, first of all, thank you very much, Elena, and thank you very much, Claudio, for your presentation. If you'd like to get in touch with us, you have quite few options. So you can go and contact us via the contact menu on our website, or you can simply request a demo. And once you fill in your details, you will be able to book a meeting directly with us. If you're interested to see the recording of this session, you can go on LinkedIn if you registered, or you can come to the Resource Center, and then we will be posting the link here. In fact, you see our product launch webinar available here as well, together with the other brochures, white papers, and video as well. We are at the end of the webinar. Thank you for the guys who actually joined online. And thank you very much for all of you that will watch us later on. Thank you very much, and have a good day.